Continuing on in section 10.3, conjugates are the sum and difference of the same two terms. The product of conjugates is the difference of squares, so we can use conjugates to simplify a quotient whose denominator is the sum or difference of radicals. In example 4 here, we're going to try and rationalize our denominator with conjugates. So to find our simplest form here, my denominator isn't as easy to rationalize as just finding the pair for what's down there. Here I need to multiply by something that'll get rid of my subtraction. So what I'm going to multiply by, top and bottom, is by its conjugate. So I keep my square root of 7, I keep my square root of 2, and I just change the sign in the middle. And again, whatever we do to the bottom, we have to do to the top. So again, to find the conjugate, I keep my first term exactly as it's written. I keep my last term, I just change the sign in the middle. So instead of being a negative square root of 2, it's a positive square root of 2. Now, I can distribute or FOIL. However, I need to multiply. So in my numerator, I have 10 square root of 7 plus 10 square root of 2. In my denominator, firsts, outsides, insides, take the sign with that, and my lasts. I'm going to simplify in my denominator now. Square root of 7 times 7. My pair of 7's come out as a 7. Square root of 7 times 2 just gives me the square root of 14. Here I have a minus, so it's going to be negative square root of 2 times 7, which is still just the square root of 14. And minus, so it's going to be negative 2 times 2 in my radical. That's a pair that can come out as a 2, so minus 2. Now I'm going to combine like terms. 7 minus 2 gives me 5. And square root of 14 minus square root of 14 is 0. So all of this in my denominator is just 5. So I have 10 square root of 7 plus 10 square root of 2 over 5. And I'm going to get rid of my division by distributing it. So I'm going to have 10 square root of 7 divided by 5 plus 10 square root of 2 divided by 5. 10 divided by 5 is 2 square roots of 7. And 10 divided by 5 is 2 square roots of 2. And I can't combine that any further because my radicands aren't the same. So the big thing here, guys, the only big difference is that to rationalize this, I need to multiply by its conjugate, top and bottom. Now, feel free to pause here and give this a try. We're looking at the simplified form of this quotient. Remember, fractions mean division, and that's just a quotient. I'm going to move it over here so we have a little bit more room. To get rid of my denominator here, guys, I have a sum. So to get rid of it, I'm going to change it to its conjugate, keep my square root of 10, keep my square root of 5, just change that sign in the middle. So instead of being plus the square root of 5, it's going to be minus the square root of 5. Whatever I do to the bottom, I also have to do to the top. So since I multiplied by square root of 10 minus square root of 5 in my denominator, I have to do the same in my numerator. Now, I'm going to multiply. So I'm going to distribute here. We get negative 3 square roots of 10. And a negative times a negative is going to give me a positive 3 square roots of 5. In my denominator, I'm going to have to FOIL. Firsts, outsides, and keep that sign with it, insides, and lasts. And again, keep that sign with it. We're going to FOIL these and multiply the same way we did in the first half of this section. So I'm going to break down into prime factors, and then because I'm multiplying, I can put both my radicands multiplied together in the same radical. So 2 times 5 times 2 times 5. Pair of 2's comes out, pair of 5's comes out. And I actually just have 10 left here. I have a negative that goes in front. 10 is 2 times 5. And I have an extra 5 there. Pair of 5's comes out. So minus 5 squared is a 2. Here it's positive, so plus square root of 5 times 2 times 5. 5's come out. And with a 5 squared is a 2. Here, negative. 2 5's. And those come out as a 5. We can combine our like terms now. 10 minus 5 gives me 5. And negative 5 plus 5 of my same square roots give me 0. Those cancel out. When you're doing these, guys, if those don't cancel out, then you either multiplied wrong or you picked the wrong conjugate. The idea here is that we're trying to get rid of the square roots in the denominator. So our outsides and insides have to be opposites. If not, you did something wrong. Now, what I get from my denominator, I put in my denominator. And because I can't take a 5 out of the 3's, negative 3 or a positive 3, I can leave my answer just like this. Okay, and the last one we reduced because 10 divided by 5 is 2. But 3 divided by 5, there's nothing that cancels out there. I can't reduce that any further, so I can leave it just like that. Golden rectangles appear frequently in nature and art. The ratio of the length to the width of a golden ratio is 1 plus the square root of 5 to 2. So another way that we can write this, guys, is length to width equals 1 plus the square root of 5 over 2. Okay, that's another way to write that ratio. So in example 5, we're going to use that idea. We're going to solve a proportion involving radicals. So fiddlehead ferns naturally grow in spirals that fit into golden rectangles. What is the width of the fern shown on page 628? This was well past my realm of construction, so I just took a picture and threw it in there. So we're going to start off with the fact that length to width, the ratio of length to width, is 1 plus the square root of 5 to 2. Okay, that's the ratio of our length to our width. And if we look here, our picture tells us our length is 4. So I'm going to plug that in for length. Now, in a proportion, we can cross multiply. So 4 times 2 is 8, and set them equal to each other. And here I have 1 plus the square root of 5 times w. The other thing we could do, guys, is we have fractions, we get rid of them. Okay, by multiplying by our denominators. And it works the same way. Rather than distributing here, since we're trying to get w by itself, guys, I'm going to go ahead and just divide. So w equals 8 over 1 plus the square root of 5. We don't want to leave our answer like that, though. So we're going to rationalize it here. So again, to get rid of a sum or difference, I multiply by its conjugate. I keep my 1. I change my sign in the middle. So now it's going to be a negative square root of 5. In my numerator, when I distribute, I get 8 minus 8 square root of 5. In my denominator, I'm going to do this over here. Firsts, outsides, insides, and lasts. 1 times 1 is 1, minus the square root of 5, plus square root of 5, and minus square root of 5 times 5. Pair of 5s comes out, minus 5. When we combine our like terms here, negative square root of 5 plus square root of 5 cancel. So all I have left is 1 minus 5, negative 4. And again, because we can simplify here, I can take a negative 4 out of 8s. I'm going to do that. 8 divided by negative 4, and then negative 8 divided by negative 4. And that one goes with the square root of 5. So, here, I get W negative 2 plus negative 8 divided by negative 4 is a positive 2 square root of 5. And that's my exact answer, but it's not very helpful here when we're talking about a specific width in a real life problem. So we're going to type that in our calculator and get approximately 2.5. So it's about 2.5 centimeters. Now, a golden rectangle is 12 inches long. What is the width of the rectangle? Write your answer in simplified radical form and then approximate your answer to the nearest tenth of an inch. So again, length to width, the ratio of length to width is 1 plus the square root of 5 over 2. Here, it tells us it's 12 inches long, so I'm going to put that in for length. So 12 over W equals 1 plus the square root of 5 over 2. We have proportions, so to get rid of our proportions, I'm going to use cross products. 12 times 2 is 24, and 1 plus the square root of 5 times W. Set them equal to each other. To get rid of my multiplication, I'm going to divide. So right now I have W equals 24 over 1 plus the square root of 5. But we need our answer in simplified radical form. So here, I need to multiply by its conjugate, I keep my 1, change the sign on my radical. Change that sign in the middle. And whatever I do to the bottom, I have to do to the top. So in my numerator, I'm going to have 24 minus 24 square roots of 5. In my denominator, I'm going to have to FOIL. So firsts, outsides, insides, and last. You can take that 5 out, and it's negative. So negative 5. I'm going to reduce in my denominator. Negative square root of 5 plus square root of 5 is 0. So I'm going to have 24 minus 24 square root of 5 over 1 minus 5, negative 4. And here, 24 is divisible by 4. So I'm going to simplify this by taking 24 divided by negative 4. And then I'm going to take negative 24 divided by negative 4. And that gets the square root of 5 as well. So here I get negative 6 plus 6 square roots of 5. This is labeled in inches. That's my simplified radical form. Now approximate your answer to the nearest tenth of an inch. When we type this in our calculator, we're going to get about 7.4 inches. Quick recap here for section 10.3. The properties of real numbers can be used to perform operations with radical expressions. The denominators of some radical expressions can be rationalized by multiplying by conjugates. And that's all I have for section 10.3.